All right, question number 4 from the notes is 3 fractions. I went ahead and wrote that out again. So let's dig in. Let's try to factor this first. So I have x squared minus 5x. That's a GCF. X doesn't factor. That's just x. And then x squared minus 25 is a difference of 2 squares. So let me write this out with my factored form. And let's replace our denominators and match them up. So this one has an x, x. This one does not have an x. So I'm going to throw an x right there and there. I'm going to put it right after the 4, but I like to put it before the binomials just for make a cleaner look. So we took care of that. This factor has an x minus 5. This one does not. So I'll write an x minus 5 there. This one has an x minus 5. This has an x plus 5. These two do not. So let's write an x plus 5 on the numerator and denominator for both of those. And I think we got everything we need for the denominators to match up. So let's go ahead and multiply and distribute all the numerators. So that's going to be 5x plus 25. This is going to be x squared, 5x, negative 5x, which cancel with the 5x, and minus 25. So that's going to be plus x squared minus 25. And I'm going to just kind of combine this all together at once. And then this is minus 4x. So those are your numerator. My denominator is x, x minus 5, and x plus 5. So not too bad. Let's look at our restrictions real quick. Again, just what makes the denominator equal to 0. So x cannot be, that's going to be 0, 5, and negative 5. And I won't write the domain for this, but the domain would be all real numbers except 0, 5, and negative 5. All right, let's combine our like terms and write it in standard form. This is going to be x squared. Looks like my 25s will cancel since one's positive and one's negative. And 5x and 4x combine to x. So this is going to be x squared plus x over x, x minus 5, x plus 5. I can GCF the x out. So it's going to be x, x plus 1, x, x minus 5, x plus 5. And I can cancel out my x's. So my final answer should be x plus 1 over x minus 5, x plus 5, or you can write that as, if you want, x squared minus 25 on the denominator. Either one is fine. I say that you can write it as x squared minus 25, implying that a lot of questions, especially like a test question that's multiple choice, might have it in that form. So you want to be able to recognize it both ways. But I'll go ahead and circle the one that I have, because usually you're just used to seeing it factored. All right. Let's look at number 5. Number 5. Number 5 and 6 kind of break form, and in the class I showed you kind of a shortcut. In this video, since I have a little bit more length to work with you, I'll show you the way to do it without having to think about shortcuts and stuff, just using the methods that we've already used. What I want to show you first is that anything to the negative first power is just 1 over that. So if I have x minus x to the negative first power, that is the same as saying x minus 1 over x. And that's the same as saying 1 minus 1 over x. So just get that in your head first, that this is kind of the approach we want to use. Now, in this problem, what I would do is I would just look at, instead of maybe multiplying both by the denominator like I did in class, let's just look at the numerator and denominator as separate entities, okay? and then we'll combine them at the end. So this is going to be, if I do x minus 1 over x, of course x doesn't have a denominator here, so I would have to steal an x from this denominator to make that work. And that's going to be x times x over x minus 1 over x, which is going to be x squared minus 1 over x. Okay, that's your numerator. Let's look at your denominator. So this is your numerator. This is going to be x, or 1 minus 1 over x. And if I steal this denominator from over here, I'm going to bring that x here and there. That's going to be x minus 1 over x. And so this is a problem like yesterday. This is a division problem. So we can write that as a keep, change, flip. You know, if I think of that fraction bar as the division sign, and I do keep, change, flip, then that's going to be x squared minus 1 over x times x over x minus 1. Well, look at the x's. Those are going to cancel out. So that's just going to give me x squared minus 1 over x minus 1. Okay, that's definitely a lot easier to work with. So we're going to factor x squared minus 1. That's going to be x plus 1 times x minus 1. And there's your denominator. And so you can see the x minus 1's cancel out. And our leftover is just going to be x plus 1. Don't worry about any restrictions for that problem. This is enough kind of thinking on its own. But you know, the restrictions would be, I mean, x can't be 0, so because x is on the denominator as a 0. So also x couldn't be 1 in this case. So there's a couple different numbers that give you restrictions on these, but I'm not going to worry too much about that. All right, let's look at our last problem, number 6. Number 6. All right, here we go. This one is similar to the last one in the fact that we have a number minus a fraction. So we're going to treat it the same way. My 3 here does not have a denominator, so I'm going to steal this x plus 2. And I'm going to write it next to the 3. I didn't really leave myself a lot of space there, but hopefully you can see I'm just multiplying it by the 3 there. And that's going to get distributed out, so that's going to be 3x plus 6. So that will end up being 3x plus 6, and then I'm subtracting 6 over x plus 2. We'll simplify that a little bit more later. This one's going to be 1 minus 2 over x minus 3. Again, I don't have a denominator for the 1, so we'll go ahead and throw a x minus 3 underneath and times that by x minus 3. 1 distributes into x minus 3, you get x minus 3, so that's going to be x minus 3 minus 2 over your denominator. And of course, this is division, so the whole thing's being divided. So this is going to be, these 6's cancel out. You get 3x over x plus 2 from the top. And this is going to be x minus 5 over x minus 3. This is another division problem, so we'll do keep, change, flip. Keep, change, flip. And we're going to write that as 3x over x plus 2. And I'll say times, and I'm going to flip this, so I'll say x minus 3 over x minus 5. Now, nothing on here is factorable. I think we kind of hit the jackpot on here. Nothing's going to really cancel out. So all we're going to do is just combine them together. This is 3x, x minus 3, x plus 2, x minus 5. And that would be our final answer. Again, don't worry about the restrictions on these ones. Just kind of look at the process there, and I guess that's it. So if you have any questions, of course, ask in class. Work on your day 3 assignment, and we'll get back in touch later.